Hi guys, welcome to GMD classes. So in the previous lectures we were discussing about inverse of trigonometric function. So in these sessions we will cover some more questions on the basis of whatever we have discussed in the earlier lectures. Okay, so some important properties were left, so we will discuss first. So I will tell. So first property is what? Suppose tan inverse x plus tan inverse y is nothing but, you can say, tan inverse x plus y, okay, by 1 minus xy. One property here. Similarly, you will see tan inverse x minus tan inverse y is nothing but tan inverse x minus y by 1 plus xy. Okay, where you can see xy less than 1, and in this condition xy greater than minus 1 if this condition satisfied. Okay, another property, that is twice of tan inverse x is nothing but tan inverse 2x minus 1 minus x square if mode of x less than 1. Okay, so these are the properties which I didn't, this property I not discuss, didn't discuss on in the previous lectures. Okay, so this property, and after that we will solve some questions. So take examples here. Suppose twice of tan inverse x is not sine inverse 2x by 1 plus x square. Okay, we have to prove, that twice of tan inverse is equal to sine inverse of 2x by 1 plus x square. Another question is twice of tan inverse x is equal to, if we take the cos inverse, then what? 1 minus x square by 1 plus x square. Similarly, if we take q1, q2 and q3, twice of tan inverse x, nothing but tan inverse, okay, this can be 2x by 1 minus x square. So we have to prove this equal to this. Okay, so how can we proceed? So let's assume, for first condition, let's assume x, we can you can see here tan inverse x is nothing but assume theta. Okay, then x is nothing but tan theta. Okay, then you put, in the case of in right sides, sine inverse of, you can say here 2 tan theta by 1 plus tan square theta. Okay, what happen if you solve this 2 tan theta by 1 plus tan square theta sec square theta? You can see here sine inverse twice of tan theta by sec square theta. If you solve further, you will get sine inverse twice of sine theta by cos theta into 1 by cos square sec square theta, nothing but cos square theta. Okay, so we will get here 1 cos cancel out, then you will see you will get twice of sine theta into cos theta. 1 is cancelled out, the twice of sine theta cos theta, nothing but sine 2 theta. Okay, so sine inverse of sine 2 theta is nothing but 2 theta. Okay, in this in the left sides you put tan inverse a theta, the twice of tan inverse is nothing but twice of 2 theta. So right side is equal to left side, that is LHS and RHS equal, so you can say that this function is proved. Okay, but twice of tan inverse is equal to sine inverse of 2x by 1 plus x square. In the similar manner you can solve these questions and these questions. If you put here tan inverse is theta, then you will get x equal to tan theta. Then in the left sides you will get 2 tan theta, 2 theta, and when you will put the value of x equal to tan theta in this equation, in this in the instead of x you will get cos 2 theta, and cos inverse of cos 2 theta is nothing but twice of theta. Okay, so this is the one types of questions. I will further take another questions. What will happen about that? Okay. See here. Suppose I have given you one questions in the previous lectures, but suppose such types of questions how can you can solve in the similar in the simple way. Okay. Let's see here. So let's assume that is sine of twice of cos inverse minus 3 by 5. Okay, how can you solve such types of questions? Okay, so this is a sine and this is the inverse function of cos. So if you will try to find try to convert cos inverse into sine inverse, then you will easily cancel out sine and sine inverse and you will get the value in the simple way. Okay, so first let's assume this value. If you assume this value, then you can solve. If you this assume minus 3 by 5 is equal to theta, nothing. Suppose cos theta is equal to, let's assume um, cos theta is nothing but minus 3 by 5. No doubt. How can, if you assume cos inverse minus 3 by 5 is equal to theta, then cos theta in a simple way, cos inverse minus 3 by 5 is equal to theta, then you will get cos theta is nothing but minus 3 by 5. Okay, since theta belongs to 0 to pi, in the case of sine theta belongs to 0 to pi, so we have cos 3 by 5, theta is minus 3 by 5. If you see here, assume in the case cos nothing but b by h. How? So if you put b is equal to minus 3 and 5, that is same. In the similar way you can find the sine theta. Okay, so how can you find? So cos theta you know, so you can find sine theta is nothing but under root 1 minus cos square theta. So 1 minus 3 by 5 whole square, 25 minus 9, that is 16 by 5, 25, nothing is 4 by 5. You will get sine theta is what? 4 by 5. Then you twice of cos, that means twice of sine theta. The sine theta in this way. So cos inverse cos theta is, the theta is nothing but sine inverse of 4 by 5, you can write here. Okay, so you can know that sine 2 theta is nothing but twice of sine theta into cos theta. How this happen? If you put this value you will get what? Sine twice of theta. Okay, but sine twice of theta is nothing but twice of sine theta into cos theta. Put the value twice of sine theta is nothing but 4 by 5. Okay, into cos theta we have calculated here minus 3 by 5. Then how this is nothing but simple mathematical calculations, you can easily find out. Okay, so you will get the value 4 3 12 12 20 24 minus by 25. So these types of questions can be solved easily. If you see cos theta, if uh, instead of cos inverse theta you will get, you have sine inverse, then you have, this is the easy simple way. How can we solve? So in this way you can solve by assuming the value by the trigonometric graphical method. Whatever you given, suppose sine of cos inverse theta, I have told you in the previous class, try to convert cos. Suppose this is the cos theta. Cos is nothing but, if you value theta is nothing, any value 4 by 5, any value you have given, then what happen? Suppose cos this is given cos inverse 4 by 5. Okay, you have to find this value. How can you solve? First, see, convert cos inverse into sine inverse. Convert cos inverse into sine inverse. How? By trigonometry, triangle method. You can say triangle method. Okay. So sorry, triangle method. How? Suppose, let's see. Take the angle any value theta. What do we have? Any value theta. Put the value cos inverse, sine inverse, any, assume only cos theta, sine theta, tan theta. Suppose here cos inverse theta is 4 by 5. So assume cos theta is what? 4 by 5. So we know that the value of cos theta nothing but b by h. So when we compare b by h, nothing but 4 by 5. Simply put h is equal to 5 or b is equal to 4. Then you will get this value 25 minus what is 16, that is 3. So if you get all the constant value 4, 5 and 3, this is angle theta, I assume. So whatever, this is the cos theta, sin theta, tan theta, nothing, we can anything find. Suppose this question is first type. Second type, I will assume tan theta, tan of cos inverse theta, nothing but suppose 4 by 5, I will assume. Similarly, sec of cos inverse 4 by 5. How can solve? Suppose if you want convert in the tan, first it is sin theta. The sin theta is nothing but what? That is the perpendicular by hypotenuse. Perpendicular is what? 3 and hypotenuse 5. So we get sin theta is 3 by 5. So sin theta is nothing but sin inverse of 3 by 5. So we get here sin inverse 3 by 5. Simple. So we can substitute cos inverse theta is nothing but sin inverse. So if you put this value, you will get here sin of sin inverse 3 by 5. This value is nothing but only 3 by 5. So no need to do such a lengthy calculation. You can only solve by taking here only. If you get 3 by 5 directly, you can say answer is 3 by 5. If you given in the form of tan, then you will find tan. Here you can find only tan theta. So suppose you are finding tan theta. So how can you find? Tan theta is nothing but p by b 3 by 5. So nothing, only we will get, in the case of tan, we will get only 3 by 5. What is it? 3 by 5, sorry, 3 by 4. What happened? So no need to do such calculation. In you can only assume here, and we will get directly put here what? Tan of, even discussing two questions, tan of tan inverse 3 by 4. You can only assume such, and you will get what? 3 by 4. Okay. Another question is what? You know, sec inverse something here, you assume here cos inverse x is nothing but, you can say here, if you assume here this sec inverse cos inverse of cos inverse x, you can say sec inverse 1 by x. Convert in this way. How? If you put here cos inverse 1 by 3, I will assume here cos inverse 1 by 3 taking, is this equal to or not of sec inverse 3? Just I assume, you can see any suppose 3 by 4 I have assumed. Okay, so this will becomes what, 4 by 3. How? Let's see. I've drawn a triangle. Let's assume theta. If you find in the cos, suppose take cos inverse 3 by 4, nothing but cos theta is nothing but b by h. Here the b is 3 and h is 4, no doubt, but I have assumed some wrong. I see, take here 5l. Okay, so that easy to find. So this will becomes 5. Okay, this will becomes 4. So if you find sec inverse x, so you know that sec theta is nothing but reciprocal of cos theta, that means h by b. So here you see h is 5 and b is 3. So cos inverse anything, cos inverse theta is equal to sec inverse of 1 by theta. So this concept is what, sec inverse, if theta is given then you can find cos inverse 1 by theta, and vice versa, reciprocal. Similarly in the case of sine also, if you given sine inverse theta, you can see here cos sec inverse 1 by theta. Tan inverse theta you have given, then you can say simply cot inverse theta. Cot inverse 1 by theta you can say. Okay, so these are the basic properties. Okay, so how can you solve such types of questions? This is the method you can solve. Okay, so I am taking another questions here. You see, so suppose I have given here one questions I am taking here. Question is, see, sine inverse 3 by 5 minus sine inverse 8 by 17 is equal to, we have to prove cos inverse 84 by 85. Cos inverse 84 by 85. So these are given in the sine form, we have to prove in the cos inverse. Okay, so sine A, sine B you can change in the order. Okay, so if you assume sine inverse 3 by 5 is equal to x, yeah, y, anything you can say, theta you assume, then what you will get, suppose I am assuming the algebraic value sine inverse 3 by 5 is equal to x. Okay, so then you will get sine x is equal to 3 by 5. What? Then you will find cos x also. Cos x is nothing but 1 minus sine square x. Okay, 1 minus sine square x, so you will get here 1 minus 9 by 25. So you will get solve 25 4 and 4 by 5. This value you can assume here sine inverse 18 by 7, 8 by 17 is equal to y. Assume. Then you will get sine y is nothing but 8 by 17. Okay, then cos y is what, suppose here 1 minus sine square y, that is 1 minus 64 by 17 is 289, I think. Okay, 17 is 289. Then you will solve, you will get here what, under root of 225 by 289, this is nothing but the 15 by 17 you will get. So this is nothing but x and this is y. So this will, question is what, x minus y, this form. This is given in the cos form, so you will take the cos of x minus y, you will get what? Cos x into cos y, cos x into cos y, minus, here is a minus, then you will get plus sine of x into sine of y. Okay, you will take sine also, but for the sine, this question is given in the cos inverse, that's why I have taken cos. If here is given sine, then we can take sine inverse, so that we can find x minus y is nothing but sine inverse, x minus y is given cos inverse. Okay, so put the value. Cos x is nothing but, how can you solve? This is here given 4 by 5. Cos y is 15 by 17. Okay, plus sin x 3 by 5 into sin y. Sin y is what here? You can see 8 by 17. 8 by 17. When you solve, so how can you solve? This is the mathematical operations. 15, 5, 3 times, you can cut it and nothing else. So then 12 by 17 plus 24 by 85. Okay, take the LCM. 85, you will solve here. 60 plus 24, you will get 84 by 85. So cos of x minus y, you will get here 84 by 85. Then x minus y is nothing but cos inverse of 84 by 85. Okay, so x minus y is nothing but sine inverse of x is what? Here you can say sine inverse 3/5. So you can say here sine inverse 3 by 5 minus sine inverse 8 by 17 is equal to cos inverse 84 by 85. So this is proved. So these types of questions are generally asked, and this is the formula basis question, nothing but you can apply the basic of trigonometric equations and you will solve it. Okay, so I want to take some more questions so that we can get more concept how can we solve. Take examples questions here. Tan inverse 1 by 4 plus tan inverse 2 by 9 is equal to half of cos inverse 3 by 5. Okay, we have to prove this given function is left side and right side equal or not. So you know that tan inverse a plus tan inverse b का formula, then you can apply and try to convert in these forms. Okay, so it's better apply the formula. How can you apply? As we know, tan inverse x plus tan inverse y, we know that what? Tan inverse x plus y by 1 minus xy. Okay, so putting the value, so you will get here tan inverse x is nothing but 1 by 4 plus y 2 by 9 by 1 minus 1 by 4 into 2 by 9. Okay, solve it. So take the LCMs. You can see 36 here. 9 plus, this is the 9 plus 4 times 8 by tan inverse. Okay, you can see here 36 minus 2, 36 minus 2 by 36. So denominator get cancel out. You will see here 17 by 34, that means 1 by 2. So this is the tan inverse 17, that means you will get here simple tan inverse 1 by 2. So this is in the tan forms, but the given function is in the cos inverse 3 by 5. So you can see here, if you, this is the left side LHS, you can take RHS and simply you can solve it. Okay, so now I am solving RHS right hand sides. Given here half of cos inverse 3 by 5 Okay, so let's assume here this becomes theta. Assume. So cos inverse 3 by 5 is nothing but twice of theta. Okay, so cos 2 theta is nothing but 3 by 5. So if you find in the tan angle cos theta 2 theta, we can change this value in the tan value, tan inverse. Okay, so cos 2 theta is nothing but, you can say, 3 by 5. So tan a, from this value we can convert into the tan theta by the triangle method. In the simple, this is, we know that the formula cos 2 theta in the case of tan theta. Okay, so what we know that here, you can see here, right, tan theta is nothing but simply sine 2 theta by sine theta by cos theta. That is in the case of you 1 minus cos 2 theta by 1 plus cos 2 theta. So we know that here this value becomes twice of sine square theta, and this value twice of cos square theta. Twice cancel, cos sine by cos tan square theta, this will get tan theta. Okay, so we know that the cos 2 theta value after solving. So how can we find tan theta is nothing but putting the value 1 minus 3 by 5 by 1 plus 3 by 5. Simple. How? 5 minus 3 2 by 5 plus 3 8 under root, that means 1 by 4 under root, this becomes half. So you can say tan theta is nothing but 1 by 2, then this implies theta is nothing but tan inverse 1 by 2. So I am getting here, okay, so I am getting here tan inverse 1 by 2 and LHS is tan inverse 1 by 2, hence this is proved. Okay, so up to this we have discussed so many questions, but all the questions are not possible to solve here. So I hope I request you to solve lots of questions so that more concept will be clear. Okay, so up to the in this session, this is the end of the session. In the next sessions we will discuss about the continuity and differentiability. So thank you for watching my video, and please like and share and subscribe my video. Okay, subscribe my channel, sorry.